Hope you enjoyed lunch. And well, we have George here, George Cushen from Farfetch, who's going to try and keep us awake. Thank you, George.
I'll do my best.
Well, I don't know. One interesting thing I have to say to introduce George is that, well, actually this is his, it's technically his first time, but well, he also tried to give a talk last year. Unfortunately, it was too late, but he did follow up, thankfully for us, because I've kind of seen what he's going to talk about. It's really interesting, so it's just over to you, George.
And this is the greater benefit of a graph. So I put a George in my graph to keep a track of everything, and next year, here I am. Thanks for the warm welcome, George. I'm George Cushen, lead data scientist at Farfetch, the online luxury retail platform. So I focus on the intersection of machine learning and knowledge representation, so things like knowledge graphs, in order to build novel solutions that can improve our customer search and browsing experience. So in the aftermath of Paris Fashion Week at the moment, and so it's a rather fitting time perhaps to talk about fashion and the retail domain. And when I was creating this talk, I was thinking, let's make it something contextual. Let's talk about knowledge graphs and AI and how these technologies can be applied to improve the customer experience. So the retail industry has undergone a massive transformation in recent years, and I'm sure you've seen many headlines in the news about a lot of that transformation. So essentially, we have the customer at the center of. We can think of the customer at the center of retail. Last year, Americans spent on average over 5 hours per day on mobile phones, according to a popular industry study. So essentially, these users consuming lots of content, and as this happens, attention span decreases rapidly, like is what's probably happening in the audience right now after a lovely lunch. Consumers are doing more things in the moment than ever before, and if we want something, we want it now. We expect to find it quickly, right? So consumers, especially Gen Z and millennials, expect a smart and highly connected shopping experience. For example, if a consumer is going to Glastonbury Festival, they might want to search trousers for Glastonbury or top for Glastonbury. And we want to be able to understand the user intent behind that. We want to understand this is a festival, the occasion is a festival they want to attend, they're looking for something for that event. And we want to be able to really tailor and personalize the search and discovery experience in the online shopping world for that consumer. There's another perspective that we can look at this as well. And that's from the marketing perspective. So generally in our online retail industry, there's a significant amount of marketing budget spent to drive new traffic to the site. So how can retailers maximize the impact of that marketing spend? Well, it's key to quickly engage those visitors and engage them in a very highly tailored manner, ideally. So hyper-personalising the product offering can help answer these questions and expectations from the consumer. And this is where the knowledge graph and AI opportunities present themselves. So we have lots of products and fashion entities at Farfetch. How can we connect them together with this yarn into a tightly knit knowledge graph? Okay, this dramatic pause is a bit longer than I anticipated. Is it working now? Yeah. I think the mouse was out of context. Yeah, one way is this. So one thing I forgot to mention is that I lead the data science team in our inspiration vertical. So I felt compelled to attempt to inspire you today with a stunning Connected Data London themed outfit, which I curated earlier. We have this lovely dotted raincoat representing all the nodes, and very suitable for this London weather. And as well, like a nice carry bag to put your phone in, so you can keep it safe from the weather, and then later check all the tweets about Connected Data London, of course. You can also buy this outfit from Farfetch, and I'm sure you'll feel truly empowered to wear it, just like this, when you're building up your own knowledge graphs in AI. So what is a Farfetch? Farfetch exists for the love of fashion. Our mission is to be the global technology platform for luxury fashion, connecting creators, curators, and consumers. And we operate a modular end-to-end technology platform, purpose-built to connect the luxury fashion ecosystem worldwide. And we're the only truly global luxury digital marketplace at scale, where lovers of fashion anywhere in the world can shop. Some of the unrivaled and incredible products that we have from our boutiques. So I thought I'd show this slide not only to show some interesting facts about the business, but also to highlight some of the interesting challenges that we face when we're building up an enterprise knowledge graph, especially one in the domain of fashion. So you can see here we have quite a number of luxury sellers, and luxury sellers can provide us with a variable product data. So one thing we need to do as a data scientist is to be able to standardize this somewhat, and also be able to predict attributes where attributes are missing, and this kind of thing. Then as well, we have various marketplaces. So we have a number of marketplace language sites. So having all these various different languages also presents another interesting challenge from an NLP perspective and AI perspective more generally, when we're building up a graph, and also when we want to perform analytics and to derive new insights and knowledge from the graph. And then finally, you can see we have a large number of luxury brands. It's a customer, let's say like a customer has a few favorite brands. We might want to, say, extract some fashion DNA from those brands, so have some brand DNA, pull out some key attributes that describe each brand, and then form like a style profile, if you like, for each consumer. And that's another application of graphs. So a bit of background. So graphs are everywhere. Many of us use them and come across them on a daily basis. I'll just dive in very quickly into one of my favorite ways to explain graphs by looking at all these connected entities which are already around us. So the London Tube network, a bunch of nodes and entities, nodes or entities and relationships. And we can apply graph analysis such as shortest path algorithm and these kind of things to derive insights such as the shortest path, and more valuable insights such as placing weights on nodes and placing weights on connections in order to consider things like traffic. So this is just a very high-level general view of the connected data in the world around us. So when we are considering connecting entities, entities can take many forms. They can be in the form of customer accounts. They can be in the form of people. And talking of connections, I'd like to mention one of the foremost leaders in connecting. So DJ Khaled, one of the foremost leaders in connecting entities, in this case music artists in the hip-hop industry. DJ Khaled does many collaborations, and he's also a fashion lover, which ties in with this talk. So why are we all here? We're here to connect. CDL provides a forum for us to connect with each other and connect knowledge, sharing ideas, insights, and of course, where would it be without sharing curated graph-themed outfits as well? So how do we represent, analyze, and visualize this kind of data? So the way we're looking at, the way we can describe a knowledge graph is as a collection of nodes or entities representing a business and fashion entities, such as a product, in this case a D&G tote bag, and some fashion attributes. Each node can contain some properties, so we can have like a product ID and a language, these kind of things. And then as well, we can have some labeled relationships between nodes, such as if an attribute has a child or if it has a synonym. So one of the key things in when it comes back to the application of a search is to be able to understand the intent of what the user is searching for, and this is where synonyms play a key role as well. So not only do we want to be able to provide like a concise mapping, but we also want to enable our customers to discover if they search a synonym or if they search in a different language for that product, so searching a translation. So at the end of it, we have knowledge represented by a huge set of dots and lines from top to bottom, side to side. And trust me, it's very challenging in the fashion business to especially to support a technology that has a visually clashing sense of style, stripes and spots. In many ways, this is a simple way to model data, though, which tends to be appealing. We usually want things to be simple. And it's very powerful, especially when the data is naturally very connected and we have meaningful relationships between our nodes. So why are we using a knowledge graph? So we have a naturally highly connected data, and they're often the key to the holistic success of the fastest growing and most successful companies of our time globally is the rapid increase in collected and analyzed data. So having this graph database and having this graph structure is a way to organize our data semantically by classes instead of tables. And another big benefit is the graphs tend to be web aware or facilitate being web aware. So we can have this superior handling for deep, complex relationships, which is not always present with more traditional SQL type of databases. And that brings me on as well to things such as a JSON graph by Netflix. So this is a convention by Netflix, and JSON LD, which is used often for enriching results in things like a Google search. So there's a number of different conventions in the industry at the moment, and this is one of the challenges we faced in building up this knowledge graph, is the metadata level, and so ideally I see there being a big opportunity here for like a universal data exchange format for graphs, in order to enable the exchange of, in this case, labeled property graphs. among various systems seamlessly. And then there's also the opportunity as well to infuse that with JSON LD and the opportunity to add more semantics into that. So we have these deep, complex relationships that can provide a rich context for hyper-personalising the product offering and inspiring customers to purchase. So some of the ideal characteristics that we look for when building a knowledge graph include something that mainly describes the real-world entities and their interrelations, organized into a flexible graph structure. Something that allows for interrelating entities with each other, so being able to form like a brand DNA that I touched on earlier. And there's something that defines classes and relations of entities in a schema. So we can look at this as a big generic knowledge graph of the opportunity to have a big generic knowledge graph for an enterprise. And we can also look at this as an opportunity to have more domain-specific knowledge graphs, such as the one we're building focused on the fashion. And there's a number of parts of that ontology that we've been building up, such as occasion, such as a wedding or like a festival, these kind of things, a celebration like a birthday, and really being able to understand the intent of what the user is looking for by developing this rich and authoritative fashion ontology. So we're mapping fashion DNA to decode personal style. So how are we doing this? Well, first and foremost, we're constructing a unified semantic fashion vocabulary that I just touched on, and then we're connecting these fashion entities with business entities in a knowledge graph via artificial intelligence, so text analysis and image analysis. And then thirdly, we're inferring DNA from the relationships in the knowledge graph. So things like being able to really derive new insights from this graph network. And we can look at this from a data science perspective, where we have a bunch of loosely structured data. So this may be some data, loosely structured data or structured data as well, that's already present in the enterprise, or maybe considering as well like external data. So we can perform some data science, some AI and or analytics to build up a knowledge graph. And then we can also employ techniques like AI and analytics on the graph itself in order to derive new knowledge and insights and fashion DNA in this case. So a couple of use cases. There's the free text search, which is the more traditional search, where in this case essentially just matching attributes. Then there's a more powerful semantic search, so being able to increase a product discovery based on using this graph to understand the consumer's intent. And then we have as well recommendations, so increasing relevance based on richer product attributes and deep graph relationships. And then another use case as well in retail that we can have is ranking, so being able to leverage these rich product connections and in order to increase the relevance on product listing pages. So one thing I often get asked is about communicating a graph in enterprise. So I thought I'd just touch on this briefly. So in terms of product managers will often ask like, how can we improve the customer experience? How can we increase the GMV? How can we make more revenue? And from a data science perspective, I mentioned this to data scientists, and they're like, "Wow, looks like a neural network. Hold my pandas, I'm on board." Because the underlying structure in the neural networks is a graph as well. And from back-end engineering perspective, why do we need a graph? Like we have SQL or we have these other databases. Why do we need a new technology, why do we need a graph database, and as well like which graph database meets our requirements. So then this is something that touches on a lot of points such as governance and migration and scalability and all of these kind of things. And then as well we can have data engineers, and one reply I've had is a bit like, is your Airflow dizzy? It's traversing through cyclic relationships. So if you've ever seen Airflow, it uses DAGs, but not quite as flexible as we have in the general graph LPG format. So moving on, building a fashion knowledge graph. Let's take a look at a couple of challenges when building our knowledge graph. So first of all, we have to consider perception. So we have the infamous dress. What do you think? Is it white and gold, or is it blue? So made up of 140 million neurons, the human visual cortex is one of the most mysterious parts of the brain, responsible for processing and interpreting visual data to give perception. We as humans can tell a lot about a scene from very little information. For example, given a blurred image of people, we can often still recognize the scene and interpret some of the context, and given our kind of prior knowledge that we have. However, we still perceive some things differently to each other, such as the color of this dress. So while perception is generally easy for humans, it is challenging for machines and often requires high order cognition and reasoning about the world around us. Fortunately for us, our photographers capture our product imagery under a highly calibrated environment. So it's a very controlled environment, the lighting is calibrated, and we have a terrific team as well of editors who correct the colors in post-production. So from a data science perspective, that's very nice. There's less challenges for us to deal with from this perspective when handling product imagery. And then our deep learning models consist of a number of layers. First learning the high-level features like edges and corners, and then later on the high-level, higher frequency details of what's present in the image. Another challenge we have is subjectivity. So fashion is a very visual medium. A lot of things that customers are looking for are challenging to capture by text alone, such as product descriptions. So how would you describe products in this outfit? It's challenging, right? Text is a great medium for describing objective attributes and of a garment, such as material. But fashion can also be very subjective. As we can see from, if you've seen any of the shots of Paris Fashion Week, which just finished early in the week, you would have seen a number of quite subjective fashion outfits that may be hard to describe in a product description. So for robustness, it's good from a data science perspective to include both the text and the visual features in our AI models where possible. So building a fashion knowledge graph. Our fashion knowledge graph tackles the incredibly complex and task of associating every product with a concrete and abstract fashion attributes from our fashion ontology or taxonomy. So this allows shoppers to search for the best products that fit their needs, like a classic dress for if a consumer searches, I'm looking for a classic dress for bridesmaids, or if a consumer searches, like I want a Swedish designed streetwear, some Swedish designs streetwear, or perhaps someone searching like a jacket for skiing. So building up a knowledge graph in this way enables us and empowers us to be able to understand the intent behind what the user is looking for. So what techniques are we using? As I touched on, we have some image analysis, so using computer vision, some text analysis, so NLP techniques. Then it's quite common that we may have a number of different terms for the same thing, and that's where conflation comes in, so being able to merge terms and this kind of thing. And then we have inference as well, so this comes back to being able to develop new insights and knowledge and things like fashion DNA. So given all these nodes and connections in the graph, what new things can we infer? And then as well, crowdsourcing. So there's opportunities in the crowdsourcing to be able to, say if something has a low confidence, be able to pass that through a peer review process. We have this multimodal, multitask approach, and where we have computer vision model, in this case something based around ResNext. So it's a very state-of-the-art method that tries to embed more subspaces compared to its ResNet counterpart. And then for NLP, we're using a BERT-based approach. So last year was a massive breakthrough year for NLP. We had models like Elmo, GPT, and BERT. Really combining the state-of-the-art and then iterating on that. So I don't have much time left, so I'll just skip a little bit to focus on kind of 360 customer view and where these kind of style preferences can fit in. So retail application of a graph-based AI and analytics, we can consider this a 360-degree view and build out a profile of style preferences for each customer based on their interactions with things like products, brands, content, and fashion DNA. Another common opportunity is identity resolution. So being able to, so the same person may create an account via multiple touch points, such as a call center or web app, and connected components can be used, and other graph analytics techniques to find that. So what's the future direction for research? Well, graph embeddings are just one way one of the concepts when it comes to the field of graph-based machine learning. There's also graph convolutional networks, so GCNs are rapidly emerging. It's a powerful type of neural network designed to work directly on graphs and leverage their structural information. And even randomly initialized GCNs can separate communities. So there's a really fascinating emerging work in this field. And that's something that we're researching at the moment, but don't have looking to put into production perhaps in the future. So there's many exciting opportunities in the research. And this brings me to the takeaways overall. So I've skipped a bit of content. I didn't stick too well to my timing. But a few of the takeaways we have is that graphs can offer a new democratized perspective on enterprise data. When graph-based analytics and AI are performed on connected data, we can derive new and powerful knowledge and insights, which can drive hyper-personalization, improving the customer experience for applications like search and discovery. Knowledge graphs, semantic, it's smart, it's alive, and demonstrated some of the real-world use cases ranging from luxury, retail, fashion, and to how we can resolve identities as well, and make which are also the key to making explainable, well-formed predictions. So. Sorry, I skipped over some of the content, but feel free to speak to me afterwards, and I'm happy to go into more detail on any specific questions you may have. And thank you very much.
Thank you, Josh. Thanks, George. Very interesting presentation. Murray here from Eigen. What technology do you use to store your graph in?
So good question. So we investigated a number of graph databases. One thing from a strategic architectural point of view is often architects like to have something that's cloud agnostic. So one of the paths we went down was looking at cloud agnostic solutions, and Neo4j is one of the perhaps the most popular down that path. Neo4j is the database that we're currently utilizing, especially as it meets our requirements as well for things like those enterprise grade features, and also be able to represent our data as a labeled property graph. So for us is very useful to be able to put properties on nodes and their relationships, which is a big benefit of labeled property graphs. Yeah.
Thanks.
Hi, I'm Vanessa. I'm curious to know, how do you deal with multiple languages? Do you have separate knowledge graphs, or do you embed everything in the same one?
So another very good question. And so the way we currently developed it is to we mapped out an ontology using the same graph. So basically, we can consider it a bit like synonyms. So in the English language, we can have synonyms. For other languages, we can have translations of those attributes and words. I think one of the challenges in this kind of area comes to when you have more like cultural variances or different interpretations of the same word, or you want to capture like maybe in the Chinese market there's a slightly different way to describe things. It may not be like a direct translation or something. So there's many exciting opportunities for us to explore down this route. And at the moment we've mapped out the ontology in a single graph.
Okay, so let's wrap it up, because well, I'm hosting a panel next and I'm already late. So
Thank you very much, guys.